started. So, let's do the first part right here. Because y'all owe me a part 2 on this project now. I know we got some time. Right, remember the project? So let's scroll down. I still got the paperwork right here. You think I forgot. I don't get nothing. I might be old, but I don't do. Hold on. My paperwork at. That'll be in here. It's y'all, right?
Yes.
Yeah. Right? Did everybody in here do this? Who didn't do it? They ain't here. Okay. Everybody signed the name, so let's say 80 points, 80%. So now you gotta do your another 20. Right? 80 plus 20 is 100. So, all right, so everybody got this done, so most of it done. So you gotta do something down here, so let's go down here to the final project. You gotta do some kind of written thing. I'm trying to make it easy for you. Easy. So go to projects. And you're gonna scroll all the way down to the bottom, right? Okay, this is us. Nobody signed in, they didn't come in on this day and sign their name and do a check off. They can't do 60. They gotta do all this other stuff. I feel sorry for them. Okay, but this is us. This is us right here. So here's your options now. I gave you options. You can write a paper, 1 or 2 pages, that explains the major components of a computer. 1 or 2 pages. Motherboard, what it do? Next paragraph. Huh? I'm gonna read it, don't get me wrong. I'm trying to see what your writing skills are, and I'm gonna probably send you a message like, this sucks, and I'll probably still get your points. You gotta can you just put more than 15-minute effort in this thing? It's gonna be over Thanksgiving, you ain't gonna be doing nothing. Or, you can write a paper, look, options. Read, are y'all reading?
Yeah.
Not all 3. Pick one. And if you want to do all 3, fine. I ain't gonna pick one. So you can write a paper. I didn't even say 1 or 2. I didn't say 5 pages. I said 1 or 2 pages. Or like one of your student classmates, she did a PowerPoint slide. It's pretty cool. I wish I could show it to her. She came in today. I showed it to you, but I got to get her permission. Real nice. PowerPoint slide. She did a slide of all the major points, and you had a couple of bullet points like motherboard does this. Boom. She got a little pictures off the internet, put it up there, and she made a little PowerPoint deck. And the other one is some kind of audio. I don't know what that could be. But I just threw it in just to give it. So if you want to do an audio with your face talking, blah, 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 blah. I'll take that too. All right? So these are the choices you have to make. Are you listening?
Yes.
Loud and clear.
Not listening. You were the one that brought this up a couple of weeks ago. Are you listening?
Yes.
This is what you have to do. Which
Right.
one you gonna do?
Project 6.
I know you're gonna do Project 6, but which one of these you gonna do?
Write a paper.
Oh, you got the paper?
Yes.
Are you sure?
Or online.
Huh?
Or type it online. On the blank.
Hold on. Let me do it this way. Cause see you gonna mess up and ask me this next week. Hold on. How do I edit this, y'all?
I have no idea. Oh, where the?
Oh, with it here right here? Okay, I'm gonna edit this, and I'm gonna put some numbers up here, cause y'all acting ignorant now. Come on. 1. Oops, did I do it right? Oops, that ain't working. These bullets not working, are they? 1. Yeah, it's my bullet. Can I get rid of this bullet? Nope. I'll do 1. I'll do it like this. How about that?
Much better.
Okay. 2. 3. And why don't I do it like this? Oops. Or 3. What do you think? Yeah, and nay. So you can't do. I'll do this. OR. All right. So you know what? Y'all see what that means, right? Don't do all 3. So I'm gonna ask you again. Which one you gonna do? Which one you doing?
Right.
Which one you gonna do? One,
Right.
2, or 3?
One.
You gonna do one? Which one you gonna do? You like one? Ain't nobody gonna do PowerPoint one?
I am.
Oh. I know that's right.
And Mr.
Okay, so when you do it, I guess what you have to do is go and upload it. How do you do that? How do you upload something?
It'll show up.
It'll show up for y'all.
When we go to submit it. it'll-
Submit it, you'll see
We
it.
attach a file.
Then you just upload it.
Box thing that you can just drag your file into.
Okay. So I can't really show some other students who've already done it. They've already uploaded, and I need to check it out, but she did a really good, where is she? She did a really good PowerPoint deck. And, I just showed a little piece, I mean, like, see, look at it. I shouldn't show y'all this, that's her. See how nice that looks? Stop looking. What you doing looking? Don't be cheating, taking from her. So she already got her 100.
Mr.
I don't know what
Mr.
she
Davis?
gonna do on Thanksgiving, but it ain't gonna be this. Alright, y'all, let's do it, let's get to work.
Mr.
Yes, sir.
Davis, would you mind coming over here? This is what I'm gonna do. If I can show you to type,
Yeah, you can show me. So don't ask me this next week now.
write
Yeah.
a paper,
Yeah, then you're gonna,
type it here.
if you wanna do it that way?
Yeah.
Okay, that'll work. That's fine. You gotta do something. Okay, let's get started. So everybody understand, right?
Yes.
Yes, you gotta turn in something.
Yes.
If not, I'm only gonna give you 80%, 80 points. All right, so where do we leave off? Let's get started so we can get going.
I need anything.
Get y'all some more networking. We are, I think we on 7. Is it 7 or 8?
Seven.
You sure about that? We are on 7, aren't we?
Cause I think the last lesson were the network thing.
Yeah, hold on, stand by, let's do, yeah, lesson 6, configuration and internet. Yeah, we did this last week. Screwed up, I forgot to do week 10. So, install the Soho network, right? You gotta do the quiz? No. Y'all messing around. Y'all getting behind? Yeah.
That's a really bad error.
What is this? Do you want to quit? Yeah.
Yeah.
Okay, so, got behind y'all. I forget which one we on. Somebody gotta help me. What are we doing? Did we do this last week?
Well.
No? Oh, let's see, Mr. D's videos, that'll tell me. No, we didn't even do this last week. Okay. So it looks like we only have one video. So this week we're doing services. So let me tell you what this looks like. Services. So I'm teaching y'all some stuff about networking. So that's what we'll do. I'm gonna do this video and then we're gonna, next week we'll do, so what did I teach y'all last week? We did the, did we not do, IP addresses and hex and all that kind of stuff?
Yeah.
Okay, cool. Good. All right. So let's do the OSI model. There's a model. This is what they call it, OSI model. OSI model. You learn this in network fundamentals. Made out of 7 layers. 1, 2, 3, 4, 5, 6, 7. Right? Did I teach y'all this year?
Yeah.
Oh, yeah.
Presentation with.
I did.
OSI model, and then there was a different model.
Yeah, called the TCP model.
Yeah, you showed this yesterday, not yesterday, last week.
Okay, so we can knock this out real quick. Bottom layer is the physical layer. It's layer 1. It's called physical. We'll knock this out real quick. Physical. 2 is the data link. Data link. What's the third one? Anybody? That's okay. Network. Good name. Network. The 4th one is, this one's tough. Transport.
Transport.
Okay. Transport.
Application.
Not application, that's up here. This one's,
Presentation.
session.
Session.
Session. And this one is 6, this is presentation.
And then the last one is application.
And this is application. That's
Application.
what we're gonna talk about today, applications. We need to talk about this model first. Okay, now, the physical layer deals with two things. Either, well, first of all, physical layer is ones and zeros. It's binary for the first. And bits. That's what we call the information in this area. And the way you get those bits is you get it on what's called a wire. And a wire can be twisted pair, coax, yeah, we did this last week,
Fiber.
and then fiber, right?
Mhm.
Okay, now, on the wireless side, that's an antenna. That's an antenna. Antenna. Okay, so that's the physical. Now, the data link is tricky. The data link is tricky. The data link deals with something that's called the MAC address, or media access control. We call it the MAC address, media access control. And I'll just say MAC, media access control. Media.
What's under twisted pair?
Coax.
Coax and fiber.
You should look on your notes. You should have this in your notes.
Yes, sir.
Let's see, media access control. That's the same thing as MAC. M-A-C, MAC, media access control. Now we call the piece of information in this area frame. Frame. See, down here is bits, ones and zeros, bunch of ones and zeros. Here is a frame. We call this a frame. It's a bunch of ones and zeros within a frame. Okay, let me tell you about the media access. Say I have a cable, coax cable. Here's a coax cable right here. Watch. Here's a coax cable. See it? There it is. What you do is you connect your computers to the cable. Connect the computers to the cable, right? There they are. Now, let's come up with a rule. When two computers talk, they all can't talk at the same time. So you gotta come up with a rule to say, who gets to talk first? So, give me a rule. Come on, give me a rule. Who gets to talk first? Is this computer 1, computer 2, 3, 4, 5? Who gets to talk first?
1.
You say 1. But tell me, what's the rule? The rule, you want 1 to talk first, but why did you choose 1 to talk first?
It's at the beginning of the line.
Oh, so you're saying you the beginning of the line. But what if this is the beginning of the line? What if this is the beginning of the line? Well, I guess it's not. So your rule is whoever's at the beginning of the line get to talk first. Okay, good. Talk. They talk, blah, blah, blah. Everybody else is listening. They're listening, right? So now when does the person get to stop? Every 2 seconds? Half a second? I
Okay.
just pulled out my hand.
Okay.
Half a second.
Half a second.
Okay, now, you know what I'm getting ready to ask you. Come on, critical thinking. Who gets to talk next?
The second one?
Who's the second? Here?
Yeah, number 2.
Okay, second one. Half a second. Blah, blah, blah. Sending out the
Yeah.
ones and zeros on the cable. Cable, physical, ones and zeros. See, we're coming up with a rule. Media, this is now also called a medium. The media is either wired or wireless. This is the media. This is the media. M-E-D-I-A, media. Media is either wired or what? Wireless, antenna, that's the media. Media, access, get access to something, right?
Yeah.
Control.
Control.
Control who gets access to the media. Everybody can't talk at the same time. So your rule said the first person that's on this cable. Okay, I said, Hey, you like it, I love it. Okay. Next person is here, then this one, then this one, and then this one.
Yeah.
Now what happens? Start over.
Yeah.
That's a rule.
Yes, sir.
That's actually a rule. That's a real rule, brother. That rule is called token.
Oh.
It is. So now, I'm gonna spell it out for you. See, I go through this every time I teach. Let's go through this rule. Whoever has the token talks.
Okay.
Eh?
Right.
Yeah.
He got the token. Blah, 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 blah. Blah, 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 blah. Blah, 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 blah. Blah, 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 blah. That's a token. Whoever has, here, token. So what the token is a bunch of ones and zeros. Blah, blah, blah. And then every device look to see that token come by. It says, oh, it's my turn. Everybody else has to shut up and listen. So if this cat wants to talk to this cat, what happens is he says, okay, I got the token. I'll send a bunch of ones and zeros, my resume, to everybody. Fans out. Guy realizes after he reads these ones and zeros, based on the frame, he says, oh, that belongs to me. I'm listening, let me just grab it. Everybody else sees the information, but it's not meant for them, so they just ignore it. Drop it, drop. One meant for me. He finished talking to this person. Then this person said, oh, it's my turn. Everybody else shut up, I got the token. Because what he'll do is he'll send a piece of information saying, I'm finished with the token, I'll send it to two. Then I'll send it, see how it's a rule. Because this rule is fair. Media, this is the cable. Access, everybody has access to the cable. Control, what is the rule that controls who gets to talk? Token. Huh? Token. You with me? Tell you an old school rule. Here's a really old school rule. Like it was when I was little. It was called polling. See, what happened in the old days, we had these mainframes, thick mainframe, right? We had these dumb terminals. Terminals were dumb. You turn them on, they would just blink. If they weren't connected to the mainframe, they just sat there blinking. And see what we do in polling, the mainframe will say, do you have some information to send me? Yes, I do. Do you have some information to send me? Yes, I do. Do you have some information to send me? He's in control. He's polling every dumb terminal. That's a rule. Is this not a cable between here and the terminal? Is that a cable? All right, in this case, there are only two devices, the mainframe and the dumb terminal, right? They both can't talk at the same time. But he's saying, hold this guy, send me some information. Hold this guy. But that is a form of media access control. The media is this cable. Back in those days, it was coax and twisted paper. Just throwing it out there. No fiber. Access, who gets to access to? I do or this one does? That's easy. This person is always going to control the conversation on the media. So we got polling, and we have a token. Here's another one. This is the one that we have now. And it's fast. It don't make no sense, but it's fast. It's called Ethernet.
That's either.
Ethernet is not fair. Well, theoretically, it's not fair. Well, I mean, when you just look at it, it's like, hey, that ain't fair. Let me show you how this works. We come up with this formula, f of x. I just do it that way because that's what I was taught at Georgia Tech, f of x. Okay, this is how it works. It says, we use this term, it's called carrier sense. Carrier sense. Carrier is the actual computer. It's a carrier. It senses if somebody is sending some information across the cable. Multiple access, where we've already done that, multiple access, media access, multiple access, have multiple devices that are accessing this cable. Remember now, only one person can talk at one time. And you gotta come up with a rule. I'm telling you the rule. Ethernet says the carrier the computer, will sense, have multiple devices that are sensing, and here's the catch. Carrier sense, multiple access, collision detect.
Collision detect.
Collision detect.
That should be good.
Collision detect. With this rule, it says, just stay with me. The rule says, if you see something that comes across, you do not send because you see some information across. And all of a sudden, when it finishes, then you can send. And you listen for a collision. Bam!
What's the MA stand for? MA?
Multiple access.
Multiple access. Gotcha.
Multiple access. Multiple access means I have multiple computers that access the cable.
Not to jump off topic,
Hmm?
would a managed switch?
Hmm?
Would a
Not
man-
yet, not yet, no switch. Yeah, you're right, a switch will do this for us, but I'm just telling you about this rule first. And we're still here,
And CS?
so we're gonna learn. Okay. The rule, let's finish with the rule. There's 3 of these rules, but the one you're gonna focus on in your, from now, is this guy right here. You gotta understand the basic rule first, and then you can make changes to it. Carrier sense, that's the carrier, is the computer. Multiple access, a whole bunch of these accessing this cable. Collision detect is the key. Collision detect says, what's my role? I'm listening. See if somebody's transmitting. If somebody's transmitting, I can't send. Did that not make sense? In other words, start talking, brother.
He's not sending outside.
I can't send because he's talking. I'm sensing him talking and I can't talk. Now remember the rules, two people can't talk at the same time. It's crazy, but it's gonna happen. Is there not a probability that when I don't hear something, this person doesn't hear anything either? Is there not a chance? We both listening. Number 1 and number 5 are both listening. Do they hear anything? Say no. What they gonna do? They're gonna send. They will send. 1 is gonna send, 5 is gonna send. If 1 sends and 5 sends, what do you think gonna happen to the signal? That's going to be a crash. Bam! I'm gonna say it loud. Bam! Right there.
Yo.
No, it doesn't cut off the circuit. It's just a signal does this. When both devices, or more, 2 or 3 devices can be sending at the same time because they don't hear anything. They all 3 want to send. So they all gonna start sending, but it's gonna be a crash. A crash in the cable. A bunch of 1s and 0s are gonna crash. That changes the signal significantly, and it bounces back. And it bounces back. And when it bounces back, everybody on the line will hear the signal. It's a crash. And here's the beauty of this thing. There's a crash. Everybody's listening now. Like, whoa! I gotta stop sending because I see a crash coming. It's bouncing back, so I gotta stop sending. Here's the key to this thing. You do what's called a back off. Okay? You do what's called a back off. Back off is this. You back off a random amount of time. Let's just say 1 second. I back off a random amount of time and I send. Just send. Somebody else hears the crash. They back off a random amount of time. What does random mean? What does random mean? It changes, right?
Yeah.
So the beauty of this formula, everybody's back off time is different. So if I back off, say 1 second, she's backing off 1.5 seconds. He's backing off 3 seconds. They all random, right?
Yeah.
I get to send. And they're like, whoa, I hear a signal, I can't send. Is that fair? Say no. That's not fair. Which one? The other way was fair. Token was fair. Whoever has the token send, right? But it's slow.
So that's like y'all.
Yeah, because right now, at the time that we were doing this, back in whatever, it was 16 megabits per second. We're doing 1 gig with this, 2 gigs, 20 gigs, 40 gigs. Here's the deal with this Ethernet. This formula says that you're gonna move so fast that everybody's gonna get a chance to send, because it's so fast. It just works. Trust me, it works. Now, if you have 1,000 devices on this computer, on this cable, then it's gonna shut down because everybody's crashing all the time. It's like, it's just everybody give up. But the point is, that is what Ethernet is based on. Ethernet is based on a rule I call it the chaos rule. It's just chaotic. You listen, you back off. Preferably, when you back off, your time for backing off is different from somebody else's time. But the formula works. It actually works. So now I just taught you CSMACD. CSMACD is Ethernet. CMSACD is Ethernet. So I've got polling, which is mainframe, and dumb terminal. The other one is token. And the third one is Ethernet. Ethernet is based on chaos theory. Crashing and backing off and crashing, crashing. It's all a bunch of crashing going on. But there's a way to stop the crashing so that all you'll have is CSMA. You'll never get a crash. That's a way to stop that. You want to know what it is? Ready? You don't care. You come up with a device that removes this long cable. So, let's look at the cable. Here's the long cable. See the long cable? Now what happens if a rat chews it right here? Here's a picture of a rat. And this is his teeth. See the teeth? And what happens if a rat chews this line? What happens to the cable? What happens to the signal?
It goes.
Nobody gets the signs, right? We all agree. There's one cable and you connect a computer here, 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 and a rat chews this line and goes down, right? Fix this. Fix it. Fix it. What can you do? No, not wireless. Come up with a device. Oh, you want to say it now?
That's managed switch.
Yes, come up with a device called a switch, where you buy this little long box, and you have some cables that connect to it. You see what I'm doing? You can go in that room. Did I take you out to the computer?
Yes.
Okay. All right. Switch is in the rack, right? Let me tell you what the switch does. It does a couple of things. The first thing is it gets rid of this long cable. So what I do is I just chop the cable up and connect it to the computers. So if the rack, there's a picture of a rack. Oh, I've got to put the ears on. Okay, you take the rack and chew this line, will it stop everybody else?
No.
Right, it won't stop everybody else. It just stops this computer. So if the rack chews on this line, everybody else stays up. That's called fault tolerance. That's good. So I resolved this issue. No long cable. I got individual long cables, and they go to each computer. What do you say to this? I love it. I like it. You should love it. Okay. Here's the beautiful thing about a switch. How many devices are here and here? 2. The computer and the jack. The computer and the jack. See, right here is the computer and the jack. All right? 2 devices, the jack and the computer. Y'all ready?
Mm-hmm.
Watch this. I'm going to get rid of collision detect. I'm still going to keep Ethernet. I'm going to get rid of this backing off stuff. I'm going to still have collision detect. Watch this. I'm going to use, and this is what we're doing now, I'm going to use coax cable. I'm sorry, did I say coax? Twisted pair. Twisted pair cable. Twisted pair cable. Twisted pair, y'all. Twisted pair. You ready? Okay. I'm gonna take the computer here. There's a network card in this computer. It's called an Ethernet card. There it is. I'm gonna take Twisted pair. Twisted pair has 8 little cables. 8 little lines, right? Copper cables. 1, 2, 3, 4, 5, 6, 7, 8. 8 cables, right? You're gonna love this. Let's do it like this. So on this side, here's my network card in my laptop. And here is a jack over here. See it? 1, 2, 3, 4, 5, 6, 7, 8. Same thing over here. There's a jack over here on this network card. 1, 2, 3, 4, 5, 6, 7, 8. Right? That means I got 8 twisted pair of little cables, right? Here's my cable, my twisted pair. I got 8 of them. So I'm gonna do this. That's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, this is gonna be my pin 1, pin 2, pin 3, pin 4, pin 5, 6, 7, and 8. Pin 1, 2, 3, 4, 5, 6, 7, 8. This is what you do. You fix it so that the jack inside the network card and the jack in the switch cross over to transmit and receive. If I can allow the network card to transmit on 2 cables and receive on 2 other cables, there will never be a collision. See if you can imagine this. I'll pick pins 1 and 2 will be received. And over here, pins 3 and 6 will be transmit. So that means I put pin 1 here goes to 3 here, and pin 2 goes to pin 6, 5, I should say 6. So if this guy transmits on pin 3 and 6, this guy receives on 1 and 2. In other words, it's like this ear, if I'm here, this ear is receiving, and this ear is transmitting. So 3 and 6 over here is transmit, and 1 and 2 is receive. See what I just did? So, you got 2 ears, right? I'm transmitting. You do this on that now. He's receiving, right? Then you do. He's transmitting, and I'm receiving. See that? We both can talk at the same time. Transmit, receive. Transmit, receive. There's no collision. You don't get it? You will. Then there's no collision. If there's no collision, I can talk and chew gum at the same time. I can talk and receive at the same time. Eh? Talk, receive, talk, receive, talk, receive. He's doing the same thing. Receive, talk, and we're both talking, and there's no collision. Yes! That's fast. What do you think?
Yeah.
That's what we are today. Right now. That's what we're doing. And we're getting 1 gig, and in some cases 20 and 40 gigabytes, or gigabits. Excuse me. That's a lot. That's a lot of 1s and 0s in a second. Buku fast. We're getting close to just using this carrier sense multiple access, no collision. It's still there, but we're getting rid of it because both jacks are doing this. Whoop. Now, if I did this straight line, then we're gonna have collision. But we don't want no collision. We don't want to do this. What do you think? Okay, so now, data link. We have three devices at the data link. We have a network card. We've talked about a network card. We have a switch. I just told you a switch. Because the network cards connect to the switch. Huh? Switch. NIC. There's one other device that's at the data link. Anybody know?
The router?
No, sir. You know what the access point is?
Oh, yeah.
There it is, right there. Right there. I'm looking at it right there. That's the access point. Let's see if I can hit it. Tear it up. Don't you say anything. Oops. I didn't do that. That's the access point. So there are three devices at the data link layer. One is a network interface card, the switch, and an access point right there. They all three work at the data link layer. Okay, we're learning about the OSM model, so we can finally get here. That's where we're going to be. Okay, now, what happens at the network layer?
You just sign your IP address.
Okay, so let's look at the network layer. The network layer deals with the network. It deals with what's called IP addresses. IP addresses. And IP addresses look like this. X dot, X dot, X dot, X. Didn't we do that last week? Dotted decimal notation?
Yes.
192.168.1, right? Mr. Darrell's chart? Did I bring up a chart? Mr. Darrell's chart? Okay. So that's what those IP addresses look like. That's done there. What device do we use here? Anybody? Router? Router? Routers understand IP addresses. Routers understand IP addresses. Down here we use MAC addresses. MAC addresses are burned in on your network card. See, the network card has a MAC address right here. MAC address. But the problem is, your computer might move to somebody else's network. So you have to be assigned an IP address on that network over there somewhere. Like my house. So right now, I'm actually connected to Gwinnett Text using my Wi-Fi network card. I have a Wi-Fi network card here. I've got it set, right? I'm doing Wi-Fi. The name of the network is GGC. Are y'all using it? Do y'all use it? Y'all actually connect? Y'all don't connect, do you? I connect. I'm connected to the GGC network using that access point right there. So I'm on the network. Yep. I'm on doing my thing. Okay. And there's a network card in here and it's wireless. So I'm connecting to that network so I can use free internet instead of using AT&T. Okay. So I have a MAC address that's on this computer. And the MAC address for smartphones is the IMI. Yeah. Whatever you said. That's the MAC address for this. It can't change, right? It doesn't change because it's on. If I go right now to Timbuktu, will I still have the same MAC address? But my network address will be different because I'll be on another network somewhere using up, sucking up their internet access, right? So at home, I gotta have another IP address because I gotta connect to a router at my house. Same thing here. When I'm on this network, I connect to the access point, which will then connect to a router and a firewall in the 100 building, so I get out to the internet. So these addresses here will change. This will not change. The MAC address on this will never change, but this will. So at the network layer, we're dealing with IP addresses. The device is a router. Anybody know what we call this piece of information at this layer? You ever heard of a word called packet?
No.
Okay, so let's see. Let's review real quick. At the lower layers, what do we call the information? Here. What do we call it?
Bits.
I should do it in red, Shimon. Let's do it in red. Bits. Bits. What do I call a piece of information here?
Frames.
And what do I call a piece of information at the network layer?
Packet.
Packets. You getting this? Okay. By the time you graduate, you should know this code, what we're going through right now. It's like drinking water. All right, so that's the network layer. Now, this layer is weird. This layer it tells you what kind of connection you have with the other computer. If it's going to be a formal conversation, or I'm just sending information to you and I don't expect a response. A formal conversation says, hey, let's talk. Let's talk. It's called a handshake, right? It's called a handshake. And what uses the handshake is something that's called TCP, a formal handshake. That means if we do a formal handshake, that means we're sending information back and forth. We're trying to have a formal conversation with each other. Who would you like to have a formal conversation with? How about Amazon? Why? Because I'm going to buy something and give them my
Debit card.
debit. Oh, I don't do that. Credit card?
Credit card.
Would you want to have a formal conversation with
Yeah.
somebody if you are giving them your credit card information? Yeah, okay. So TCP loves formal conversations. So stay with me. Going into to what we're going to talk about today. Some applications love TCP. I just gave you one. A web browser talking to a web server on Amazon. I want a formal conversation. I'm going to use TCP/IP. TCP/IP. Always going to be IP here. TCP/IP. Formal conversation. So you want to say handshake? You remember this one? Handshake? Let's do blue. Blue on this one. So let's do handshake. Handshake. How about that? Handshake? There's another protocol or rule that is a transport layer that does not require a handshake. They just send the information. You get it, you get it. If you don't, you're gone. Just ask me again, I'll try to send it again. You keep asking me, hopefully you'll get it. I'm not expecting, matter of fact, I don't want you to respond to me. I just give it to you. What kind of conversation is that? There are some applications that use this one, and it's called, anybody know? UDP. Transmission Control Protocol, User Datagram Protocol. I think UDP. There is no handshake on this. We call this connectionless. We call this one connectionless. Does not require a handshake. So I would never, me personally, I would never use, if I'm designing an application, I would never use UDP if I'm going to do credit card stuff. E-commerce? No. I use this one, TCP. What do you think? You there? Almost there. Almost here. Okay.
Question?
Yes, sir. Ask me some questions, brother.
It's like a security thing, TCP versus UDP.
I wouldn't say a security thing because actually it's not secure. You gotta make it secure. Yes. It was designed not to be secure back in the 80s, 70s, because they ever thought about the internet. Actually they did, but they didn't think it was gonna be like it is today, where we actually make transactions over the internet. So when they designed TCP, TCP/IP, there was no security. It was like a bunch of colleges connected to each other, and then the Department of Defense. And they never thought about hackers. They didn't think about no hackers back in the day. Man, they just, they're just riding these big cars made out of steel, killing each other, just smoking dope, and just living the life of luxury, right? Look, the way we communicated back in them days, and I remember, is to go to a payphone and talk. There was no internet, man. There were no phones, there were no beepers. Hey, how you doing, baby? I'm coming up. I'll be there in 30 minutes. Hopefully she there and pick up the phone, right? That's how we communicate. But now, we making billions and trillions of dollars on the internet. Now it's up to y'all to come back. That's why you in cyber. You got to make this scheisse. You got to make this scheisse secure because it ain't. You with me, brother?
Yes, sir.
All right. Okay. You got this? So transport layer, we got TCP, handshake. See, he gonna remember handshake. you gonna always remember handshake, because we handshake, right? You're gonna know that handshake means TCP. And UDP, I don't know if you're gonna remember that or not. It's, just send it, you don't get a response. We good? All right, now this one's easy. Y'all ready? Session start, maintain, stop. That's all I can tell you about this one. I'm done. I don't know what else to tell you. It's one of those kind of vague. I'm like, it's easy for me to remember because it's like 3 words. You start a session, here's what happened, brother. We start a conversation, right? We did a handshake. Then I go to the next layer. It's like, let's start talking even formally, come up with these session IDs. Like, there's the ID, we talk, because we gotta hang up, we gotta start over again, right? So that layer is this one. We start the session with somebody on that side. And then we maintain the session, and then we stop the session. Now notice, you'll never have UDP use session. Not really. There are times you are. Let's just say no for that. Because we're just learning the basics, right? So UDP doesn't really like that one. Because, this one assumes it's TCP, formal handshake. Now let's start talking back and forth with some session IDs. ID 1, ID 2, ID 3, ID 4, right? Okay. Now this one I like. Okay, here we go. This one's made up of 3 things. One is, I'll do the first one, and then I'll come back to it. This one's called data, format, translation. I'll come back to this and I'll show you an example. Data, format, translation. This one, we take a resume. Just use a resume. I want to send resume to my LinkedIn account. So what I do is I write up my resume in Microsoft Word. Now, I have to translate it into what?
Bits.
Right. That's what the presentation layer does. The part of the presentation layer that takes your document, whatever it is, and converts it to ones and zeros. It could be a database of all the students that are in Gwinnett Tech. And how many is that? 11 billion. It's a big database. You convert it to ones and zeros. Data format translation. The next thing it does, this is real easy. You take that information and you compress it. So it does compression. Why would we do compression here? Maybe it's really big, we don't compress it. So compression is done at the presentation layer. That's all you're doing. You're trying to figure out what's done where. Okay. The third one is, this is real easy. Encryption and decryption. Encryption. So it looks like the presentation layer does 3 things. Data format translated. You take some data and you format it to
What's
ones and zeros.
underneath compression?
Huh?
What's underneath compression?
Oh, I'm sorry. Encryption. Encryption, which is with a key. Compression, you compress on this side. You send the information over here and you decompress. All right? Encryption, you take the information ones and zeros and you encrypt it with a key. You take the information over here and you unencrypt it with a key. Now what y'all gonna learn is how we get the keys. Now I ain't going there with you. I wanna just teach you the OSI model. Okay, now, I'm gonna give you an example of this. I know we're going over with the break. Let's just keep moving because we're gonna leave in a minute. Okay, so let's do this. I'm gonna show you how this works. This format translation works. We have this table that we use in the computer world. It's called ASCII. ASCII table? You ever heard of it? You have? Really? Since you said it, you gotta explain it to everybody. See how you messed up? See, in my class, when you answer, you teaching that day. So let's go and look at an ASCII table. See if we can find it. How you spell it? ASCII?
ASCII.
Table? Okay. This is built into all computing devices. Probably the operating system handles this, I guess. What's up with the network, y'all?
Government shutdown.
Government shut down their Amazon wireless businesses.
Why is Amazon still jacked up?
Not everyone's using it at the same time.
Man, we're not gonna be able to do this. There it is. There it is. Let's see, let's look at this cat right here. File version. I don't like this one because it's not doing it in binary. I don't like that word. Can they not use that one? About this one? Trying to find one that shows you zeros and ones. That doesn't do it either. I want to see one that shows you ones and zeros. Dang, man. Well, I guess I'm gonna have to go back to this one right here. Okay, this one you'll understand. Well, maybe you won't. Let's see binary ASCII table.
This is
ASCII.
the binary.
Where do you see it?
Right
Here, here,
No, when you search it up, it's right there. the second
here.
No, your second drop down.
Second drop down. Here,
No, no.
one.
Go back
right
up
to
to
the
the-
search bar,
here.
and then right there binary.
Thank you. Let's see if I can see it. Yeah, it's still not showing no pictures though.
That's
Images.
good.
Trying to find it so I can just show you. This is it. Come on. God, this is slow. This is awful. Oh, yes. Yes, that's it. That's an ASCII table. Okay. You see it? Okay, look at the letter A. So look, think about my resume. Mr. D. Mr. D? Is that an M up there? Okay, M. Lowercase m, so that there is definitely a number for uppercase M too. Mr. D. Okay, so here's my name in my resume. Mr. D. Mr. D, right? So I see an M, a R, a space, a D, E, E. Turn the M into ones and zeros. Where is it? Oh, that's an M, big M right there. 0, 1, 0, 0, 1, 1, 0, 1. Everybody agree?
Mm-hmm.
So the M would be 0, 1, 0, 0, 1, 1, 0, 1. What about the R? Little R. 0, 1, 1, 1, 0, 0, 1, 0. 0, 1, 1, 1, 0, 0, 0, 1. You see what I'm doing? So I'm taking this table, this ASCII table, and converting it to binary. I'm gonna go ahead and tell you now. Let's just go ahead and pick an application up here. Microsoft Word. Do we all agree that Microsoft Word is an application?
Yeah.
Okay. Can you see your resume in Microsoft Word?
Yeah.
If you use this model, you take this resume, you want to send it to LinkedIn webpage. You're going to use this model of, the OSS model is about communication. What are the steps to communicate with a Linksys, not Linksys, LinkedIn server? I'm going to send my resume. You got to start with the resume. You type the resume. Mr. D's resume. But now you go to the next layer. You got to transmit the resume. You go to the next layer. This layer says data format translation. You translate whatever it is you're trying to send into what? What? Right. Binary. Ones and zeros, y'all. Can you not see it?
Yeah.
Okay. So I did the first two letters for you. There it is. I've done it. I just converted MR into ones and zeros. You want to see it in real life? Okay. We're going to do this. We're going to do this. We're going to leave. All right, I'm going to close this. No, we're going to do this. Because visual, I'm a visual person. I'm going to say ASCII to binary converter. Oh, there it is. Give it to me. Okay, watch this. Text to binary converter. All right, you ready? All right, watch this. I'm gonna go to Microsoft Word. I'm gonna do it the right way. You got time. Y'all ain't learning that anyway. Microsoft Word. Okay. I'm just gonna create a resume. Mr. D resume. R-E-S. All right. Okay. Ready? G-A. I teach. TEAC, computer courses. Degrees. I got a lot. Huh? My car is a Honda CRV 2015 with blah, blah, blah miles. Okay, huh?
Yeah.
That's my resume. What? She said, Okay, copy. Y'all ain't listening.
Huh?
Now I'm getting ready to do the next layer, which is presentation layer. Converts, in this case, text to ones and zeros. All right, so let's do it. So I'm gonna put it in here, paste. All right, is that not there? Including the spaces too. From text to man.
Man.
Okay, now watch this. Here's the deal. There are actually two tables. ASCII's been around a long time ago. It's like it's all ones and zeros and A through Z, uppercase, lowercase, blah, blah, blah. But see, ASCII doesn't convert what y'all young people like to do. And that's called emojis. When I was coming there was no such thing as an emoji. You know, like, right? You know what y'all do? You know, whatever y'all saying, emojis, right? So they had to come up with another table that has emojis in it. And you might have emojis that might be in Arabic and also in French. Huh? Okay, whatever. So we come up with another table called UTF-8. And that's even another table called UTF-16. Got even more emojis, huh? Go tell on me. I'm gonna say I'm gonna deny it. Okay, so now this is saying convert this using the ASCII UTF-8 table, because I could put an emoji in there, right? That, but okay. Then I'm gonna see convert, and you tell me what you see when you do convert. So y'all ain't ready. I ain't got time for y'all. Bye. Is that not the presentation layer? Did I not just demo? I should get paid.
Yes.
Okay, this is I'm teaching him. I should get extra. Okay, so what I just showed you is you can take any application, which we get ready to do, one video, we gone, and go to this layer. Now, once you're at this layer, you might do some compression. You might, you don't want nobody to see it, right? So you use a key to encrypt it. That's another story for another day. And then it goes down to each other layer. Handshake if you need it. No handshake if you don't. Then you go down here and you slap on the IP address. Then you go down here and put it in a frame. Then you go down here and put those ones and zeros on the cable or the, come on now. That's communication. Yes? All right.
How does the compression work?
Hmm?
How does the compression part of it work?
It's another algorithm, it's another formula. Just takes those ones and zeros, and if you see a bunch of ones and a bunch of zeros, you're represented with a 1 or you're represented with a 0, that kind of thing. A pattern. If you keep seeing the same pattern, you can say in the compression software, because now if you compress with something that's called zip file, zip it. There's a program called Zip, there's another one called 7Z. Y'all know what y'all young folks do, right? But if you you encrypt with that formula, you gotta unencrypt with the same formula. Am I not right?
Mm-hmm.
See, I don't encrypt nothing, because I don't do nothing. Okay, you feel me with that?
Yeah.
But it's still gonna be ones and zeros, but it's gonna be compressed because you're using this funky formula. And as soon as you go to the other side, you're gonna say, oh, here's a file that has a .zip on the end of it. I need to go to the presentation layer and use the same formula he used to unencrypt.
Right.
All right, that's how it works, brother. All right, so now let's do this. 9:30, no break. We're almost finished. All right, let's talk about the different applications. Y'all wanna do that? Yeah. I think we only have one. I think we did a pretty good job today. I think, because I'm already tired. So we're here, right? 7, lesson 7. Got 2 labs, y'all. Fix a network connection. Troubleshoot a network issue. I might just get one of y'all to do one of them, so they can say, you don't do any labs, Mr. Darrell, you do good instruction, but you don't do, what am I doing? Oh, Mr. Dees. See, alright. Here we go. Now, I'm gonna go ahead and tell y'all this so y'all can start learning this stuff. You don't have to do it for this test or anything like that, but you gotta know this for your other classes. There are different types of applications that we use in networking. This video is just gonna tell us what those applications are, and it's gonna assign a number to those applications. So I'm gonna give you the first one, it's easy. A web communication, using a web browser, talking to a web server, using something that's called HTTP. Everybody ever heard of that?
Yeah.
Okay, there's a number that's associated with HTTP. Anybody know what it is?
80.
80. So whenever you see 80, you should automatically know web browser and a web server. Now, what if you want to make it secure with a key? It has a port number. It's called HTTPS.
443.
Port number for that is
443.
443. That's all this is. So he's going to just talk about a bunch of port numbers associated with an application. That's the last one.
Society does try to put us in a box, especially female athletes, but you can't.
Okay, here we go.
What is a port? So that is the topic of this video. Now, a port is not a physical connection. It's a logical connection that is used by programs and services to exchange information. It specifically determines which program or service on a computer or server that is going to be used, whether that is pulling up a web page, using an FTP service, accessing email, and so on. And ports have a unique number that identifies them. The number ranges from 0 to 65535. For example, some common ports are port 80 and 443, which are used for web pages. Port number 21 is used for FTP, and port number 25 is used for email. A port number is always associated with an IP address. An IP address is a numeric address. It's an identifier for a computer or device on a network. Every device has to have an IP address for communication purposes, and an IP address and a port number work together to exchange data on a network. So for example, if you want to connect to a server over the internet, the IP address is used to determine the geographical location of that server, such as what continent, country, city, and so on. And a port number determines which service or program on that server it wants to use, whether that service or program is a web page, FTP service, email, and so on. Now, in simple terms, what does this all mean? So as an example, let's take a very common port that just about everyone uses every day, and that is port number 80. Port 80 is associated with HTTP, which is web pages. Whenever you visit a web page from your computer, you're using port 80 whether you know it or not. So let's say you're sitting at your computer and you want to visit Google's web page. So you would open up a web browser and then you would type google.com in the address bar. But before your computer can bring up Google's web page, it has to do a couple of things first. It has to convert the domain name of google.com into Google's IP address. And in addition, since you're using a web browser which is using HTTP, your computer is going to add port 80 to the IP address. So now the IP address is going to be used to locate Google's web server. Then once the server is found, the IP address has done its job. So now it's the port number's turn. And Google's web server will see the incoming request with port number 80 and will forward that request to its built-in web service so you can finally retrieve Google's web page. Now, all of this is happening behind the scenes. You don't see the IP address or the port number that's being used. However, there is a way that you can see it, and that is by using the netstat utility. Netstat is short for Network Statistics, and it's a command line tool that is used to display the current network connections and port activity on your computer. NetStat is available on various operating systems, but in my example, I'm gonna be working on a Windows computer. So at a command prompt, you type in netstat, and then we're going to also use a -n subcommand, so we can see the actual port number, and then we'll press enter. So here in the output, we can see our connection to google.com. The local address is our computer here, along with our IP address. And here's the port number that our computer has assigned itself for this session. The foreign address is google.com, so here we can see the IP address of Google's web server, along with port number 80 that's being used for this connection, because as I said before, port 80 is used for web pages. Now,
What happened?
now let's say on the
Tell me this, am I using TCP or UDP?
UDP.
Am I using TCP
Oh,
or
TCP.
UDP? Why do you know it's TCP?
That's the protocol.
Oh, because it says right here? And why is he using TCP instead of UDP?
Yeah, and-
Talking to a web server. Web servers love to use handshake, so TCP? TCP. And? Okay. Good. Where are you? We finished? Oh, no, we didn't. Oh, we finished.
before, port 80 is used for web pages. Now let's say on the same exact server, Google is running an FTP service where clients can transfer files.
What port number does FTP use?
21.
21. Anybody heard that? What you guys gonna have to do in order to pass these tests, you're gonna have to understand these port numbers. So I see 3 port numbers so far. One is HTTP, port 80, HTTPS 443, FTP is 21.
FTP is a standard protocol that
Actually,
is
it's
used
20 and
to
21.
transfer files between computers and servers over a network, and it uses port number 21. So on our computer, we can open up a web browser, and as an example, we'll type in ftp.google.com, and then we'll see the same thing happen again. The domain name of google.com will be converted into Google's IP address, and since we're using FTP, our computer will add port 21 to the IP address. And once Google server sees the incoming request with port number 21, it'll forward that request to its built-in FTP service. And if we do the same netstat command again, it'll show a connection to Google's FTP service using port number 21. So as I stated in the beginning of this video, port numbers range from 0 to 65535, and they are assigned by an organization called the Internet Assigned Numbers Authority. And these 65,000 port numbers are broken down into 3 categories. Port numbers from 0 to 1023 are called system or well-known ports. These are common ports that most people use every day, and I've mentioned a few of these ports already, such as port 80, 443, 25, and 21. Port numbers from 1024 to 49151 are called user or registered ports. These are ports that can be registered by companies and developers for a particular service. And you can see some of those examples here. And port numbers from 49152 to 65535, these are called dynamic or private ports. These are client-side ports that are free to use. These are the port numbers that your computer assigns temporarily to itself during a session. For example, when viewing a web page. So of these 3 categories, the top 2, which are the well-known and registered port numbers, these 2 categories are used on a server. In other words, these are used on a server that our computer connects to. But the 3rd category, which is the dynamic or private port numbers, these are used on a client, meaning our computer. It's what our computer assigns itself during a session. So whenever our computer wants to use...
He's saying these are temporary, so when I turn my computer on and want to go to a web server, I'll type in the IP address of the web server, and it'll say 80, because I'm doing web. Well, probably it's going to be 443, but that's secure. Most time you go to a web server, you're always gonna use HTTPS. So that's 443. But over here, I'm just gonna pull a number out my butt. Next time I go to another web server or the same one, it'll be a different number. I just pull it up. It's called random. You pull a number randomly. 1 minute it might be 49550. Next time you go to the web server, it might be 55881. So these are random. Every time you do something, they just come up with a different number. So these are gonna pretty much stay the same. If I'm gonna go to this web server, I'm gonna go to the IP address of the web server and 443. Secure. That's all these things.
Use a service or program on another computer or server, it assigns itself one of these port numbers. Now, sometimes on your computer, you might see well-known port numbers being used, such as port 21 and port 80. So for example, if we do a netstat with a -an subcommand, we'll see port 21 and port 80 that are either listening or have an established connection. And as I stated before, these port numbers are used on a server and not on clients. However, servers aren't just large and powerful computers. Your computer can also act as a server for other computers to connect to. For example, if you happen to be running an FTP service or running a website on your computer, you're going to see port 21 and port 80 that are either listening or have an established connection, because you can configure your computer to act as a server that accepts incoming connections. So let's put this all together and do another example. So let's go ahead and have our computer connect to a couple of websites, such as yahoo.com and example.com. And then we'll also connect to a separate FTP server. So now if we do the same netstat -n command again, we'll examine the output. And here we see the local IP address of our computer along with the dynamic or private client-side port numbers that's being used for that particular session. And then we see the two IP addresses of the websites that our computer is connected to, along with the port number, because port 80 is used for websites. And we also see the one FTP site that we are connected to using port number 21.
Okay, so here's me. My address is 192.168.0.12. So now I want to connect to this cat over here. 22.134.45.78. And I guess I'm doing what? I don't know. 80. So that means this is the web server, Yahoo. I'm gonna pull a number out my butt. Watch. I'm gonna pull a number. The number I pulled out is this guy right here, 62976. That's me. But I want to talk to 22.134.45.78. But the port number is 80. 80 automatically tells me this is the web server. All I gotta see, all I gotta do is do this netstat, go to the terminal. You know how I taught you how to do the terminal, you know?
Yeah.
Okay, go to terminal, type netstat space dash, in this case N, you do NA, all kinds of parameters. I just do N. He's only connected to 3. If you were to try it right now on yours, you'll have a whole bunch of stuff that'll go down. But he's only did it for 3. So he's connected, and it says established. It's telling you that he's established with this server, he's established with this one, and he has established connection with this one. And that's all he's doing. And the numbers are the key. So 80, 443, 21, when we do 3 or 4 more, I'll tell you about. And do you understand? Finish up.
Now, just to clear things up, if you use this netstat command, a lot of times you may see port 443 instead of port 80 during a connection to a website. And this is because both of these port numbers are used for web pages, but the difference is that port 80 uses HTTP, which are for regular unsecured websites, but port 443 uses HTTPS. And the S stands for secure. It's for viewing web pages that have a security feature. And a lot of websites are now using port 443 instead of port 80. Hey guys, I just want to mention that if you want to increase your knowledge in the network,
No, we don't. Okay, so let me get these other numbers and I don't have nothing else for you. So, let's see, we got 3 so far, right? We got HTTP, that's 80. HTTPS, that's 443, right? 443, 80. And then we have FTP. These are all applications. FTP, that's 20 and 21. 20 and 21. How about I give you an email server? Email server is
25.
SMTP. What port number is that?
25.
That's 25. Let's do DNS, because that's a big one.
53.
DNS,
53.
53. How about something that's called DHCP?
69.
Gotcha.
69.
69, right? I think it's 60, it's 2 of them.
68, 69.
You think so? I'll just do 68 and 69. You check it right quick. Somebody check it right quick.
67, 68.
67, 68. That's okay. That's what I did. I thought it was 66. I get them confused. Those are the main ones. They're like 15 others you need to know by the time you graduate. I just gave you 1, 2, 3, 4, 5, 6, and a whole bunch more. You got. Tell you what, I'm gonna upload a text file that shows the port numbers I think you need to remember code by the end of your graduation. So, all right. So let's see. I did not follow the things I have to do, but I see only 2 required. I see only 2 required labs. Think y'all can do these? Fix a network connection and troubleshoot a network? Now, I tell you what, if you don't have some problems, I'll do them next week. I'm tired. Bye. We'll do the sign-off sheet next week.